All right. So this is the project start video. Gotta kind of like gather my thoughts here on what to talk about. So I'll post a like where we're at with the project's components, I guess. So one of the pictures that, so if you look in the group chat that we have going, there's a picture of all the electronics, like that picture where it just looks like kind of a Lego octagon. That's everything that we have besides the motors, the batteries and the pendulum, and the like just connections between all that. That's everything. But I'll take a picture of this. But this is like a really quickly drawn up schematic, basically, of what is on that. That's like the plate. So the main components of the project are the shell. So the shell needs to open somehow. That's one of the biggest problems, is that it's just a shell right now, and we need a hatch. So the shell, the plate, which hopefully that'll be like a level plate at some point. Right now it just kind of rocks with the pendulum as you go. You'll notice like the plate will go with it. And then the pendulum, and with the pendulum is the flywheel. So the pendulum sits here. Let's just do this. So flip it. There we go. All right. So this is a shell right now. It's a rabbit hamster ball from Petco, and we have two of them. One of them is in the video that I'll share, and this is one that we kind of came up with this idea for maintenance reasons, and that, you know, like modifications are constantly made to this. The way that you actually have to connect it is you put the lid on here, it just goes in like that. You flip it, then you put the actual robot in there, then you put this on, then you have to like kind of clock this on, like put it just right, and a pin goes through like right there to pin it on both sides. There's a pin that goes through the robot, if you notice, and there's a pin here and a pin down here to pin it to the shell. And then each one of these on the stock one was screws, and you had to screw it all the way around. This one we just put magnets, and I actually made a mistake. And if you notice, so the first set I meant to line up, but I actually made it so that north and north, or south and south, where the poles were identical. And so now it only goes on like in the clock position, but every magnet still holds good. Like that magnet, it's grabbing. They're all neodymium magnets. And so now it just clicks in right where it needs to go, and it's solid. It's pretty solid. So I think that'll work. So still getting the robot in there quickly is kind of an issue. And this is just some stuff I was messing with. That's not something that's going to stay there. But so that's the shell. let's see. So in the video I literally just came back, the bottom, so the flywheel on the bottom of the pendulum it holds all the batteries. So let's do this. Hang on, sorry guys. Do something like. All right, there we go. There. All right. So you have like the pendulum arm. So like a simple version of this would be the shell, one half of the shell. This is the other half of the shell. It actually has that seam here. This would be where the magnets click together. This is the pin that runs through that actually holds everything in position. It's connected here and here somehow. We got to figure out the best connection. Right now it's just a cotter pin that's slid through a hole that's drilled in the steel pin. So essentially these are components: the pin, the shell, something that brings the pendulum down, a pendulum that is allowed to rotate, and let's say rock like this. So the pendulum can rock and it can spin, and our spin is our turn and our rock is our forward and backward. So this is a component, this is a component, the shell is a component, and then the whole purpose, which that is another thing that actually needs to be completely hammered out, or at least just like a specific mission for it. So the idea is that it holds drones on this level platform. So drones would sit here, wherever on this plate. The plate would be level or semi-level, self-leveling, semi-self-leveling, whatever you want to call it, and it will take these guys to where they need to go, and then the drones can fly out of this. So we still need an actual hatch that can open. It doesn't really have to be powered. It could just be that it's mechanically opened by us, but the biggest goal, the end goal would be for this thing to be able to at least be remotely driven somewhere. Then you do whatever you need to do from the remote to open it and let the drones out of it. So the hatch is a big one, and then the level plate is one. So everything is going to need proper designing and proper like planning and engineering for each one of the components. So the pin, what materials, why we didn't use some materials, and why did we choose this material. So we should just kind of track that along the way. It's going to be much easier to finalize this whole project if we just constantly do the boring paperwork portion of each one of the things we need to engineer. But I think we can quickly get a lot of this stuff down. So this battery box, this is where the batteries are. So And just so you guys know, I'm only talking about structure right now. So for structure, we have the shell, we have the plate, we have the pin, we have the, say, pendulum slash battery box. And, you know, of course, like little stuff, you know, how do we mount the motors? What gears do we use? Things like that. So that's the structure part of it. The electronics, we have a Raspberry, Raspberry Pi. Right now we have, they're called motor hats, and there's 3 of them. The reason, so we have 4 motors total. We have 2 that operate the rocking, and then we have 2 that operate the spin. And the reason that we have 3 hats and not 4 hats is because the spinning takes a lot of juice and the rocking doesn't really matter. Just for what we had for initial prototyping. So we do have 4 hats, but these aren't smart to use. You can make your own hat that does whatever you want it to do. You can also, they have a motor hat that will run 4 motors out of it. This portion of it, again, it's the same, just like structure. This is going to be a whole, you know, design, thinking about what we can use, why we're using what we're choosing to use, and why we're not using what we're not choosing to use. So Raspberry Pi with the hats, there's a power supply that is just for the Pi. So you plug in like 110 into it, and then through a USB cable you get power out. Plus it has you know, a LiPo lithium polymer battery on it. It's just like another hat, just to supply power for the Raspberry Pi. One thing we did notice about Raspberry Pis is that there is they're very sensitive to just pulling the plug on them. Maybe, I don't know, like they're doing some weird stuff, but it does work. And we can talk more about the details when we meet up. What am I forgetting? Okay, so the way the prototype is, it's Lego. And so, who just showed up? Yeah, all right. I'll just keep talking. I don't know who that is. But anyway, the main, or the prototype is Lego right now. So, and obviously we're not using any Legos in the final project. So these motors, hopefully we can design it down to 1 and 1. So 1 good high torque for each, whatever you call that way we need to go. So we've been calling this rock, for rocking, and this one's spin. So hopefully we could just, you know, there's no reason we can't just get a 1 motor to do all the rocking, 1 motor to do all the spinning, and the batteries and speed controls, however whatever we need to do to make these operate correctly. So let me just Top chats. Let's see. There we go. All right. So since we are using Lego, so right now we have these like Lego connectors for the motors, and so we go from the Pi, from the power supply to the Pi, to the hats, to the wires, then Lego conversion of the wires, then to the motors. That's essentially how we send power to each one of the motors. Spin and rock, they're all the same thing. So they have like these Lego wire adapters. This won't be part of the project, obviously, but it is part of the prototype. And the last thing is a Sense hat. It's like, you'll see it in the video right now. It's got like this rainbow display. It's like the stock display that comes. So it has like all these LEDs, has an accelerometer, I think a barometer, a temperature, a few other things. It's just like a Sense hat. I have it mounted in the front of the thing to just change these colored LEDs just to white, so it kind of looks like a headlight sort of for right now. There wasn't a whole lot of planning that went into all that. It was just, I thought it looked cool. So that's the electronics. So motors, big time. We need like to find out, do we need to spin fast? Do we need to spin quickly? Do we need to accelerate quickly? Or do we need to spin with speed quickly? And how much torque do we need? And then once our motors are designed, then we could do what needs to power the motor. So what do we need? Did we go brushless? Did we go brushed? And then brushless is much more complicated. We're going to have to use ESCs, and we'll talk about those. We'll all get together and talk about all those details later. But motors, and then things to run the motor. So let's just say Raspberry Pi stuff, including the Pi, and then all associated wires that go with that. And then the other big thing is the batteries. So that's basically that's the whole project. As far as, I mean, this is basically just telling you guys what all the problems are, but we have like a fairly quickly, it'll be reliable system right now. It's very, like, all the things that would break on you, we hashed out a lot of those. Like the wires, they're solid connections now. Everything has like a good solid foundation to base the project off of. So I would, let's see. So yeah, out of all the goals that we set to get the prototype up and running, for, to make sure that everyone was still motivated with the project, and everyone still, was confident that this thing would actually move. We really wanted it to move. We really wanted it to actually have a easy way to turn on and off, and an ability to charge by just basically plugging it in. So the easy turn on and off isn't there yet, and the ability to charge it easily is not there. But we got it to move, and we got some other side parts hashed out. We currently have 5 Raspberry Pis because we're learning stuff. So so there's going to be a lot that goes into this, and I don't know, I think we have like a really good team that, like, this part, which most teams would be very scared of, I think that we're gonna excel in. Like, this is gonna be great. This part, this is gonna be very challenging, but this is pure mechanical. Like, this is all materials, design. Just, this is where we're all gonna shine. So, yeah, I just want to make this video to, you know, let you guys know kind of where we're at. Again, I'll post that that one video that we just took today. It actually looks like we went backwards, kind of, but we didn't. There's a lot of stuff that's reliable now and it's solid. It's just that we're a little too big now, so the fitment was weird, and with our schedules we kind of just had to stop here. But you guys will see it's very nice. It's very clean looking, and so I talked with Professor Gotzi about what we wanted to do about meeting up. And so if you guys want to get on the group chat and just mention your schedule maybe or something for the first week, or just, I don't know, we'll figure it out. He said that he's not going to be around on Monday, so I'm pretty sure we all have that mandatory senior project meeting on Monday anyway, so maybe we could all get together for a second and at least talk about a few quick details or something. It'd be a lot easier to explain this kind of stuff if people are asking me questions and I'm not just rambling on trying to think of things. So yeah, we're gonna have like an initial meeting at some point. We all gotta kind of agree on whatever that is, and then we were gonna talk about maybe doing, like, you know, you have to meet at least once a week, so we should do a meeting where we get together and talk about the business related portions or what we figured out, and come up with game plans and goals and whatever. And we could just do that in like a quick meeting that we have, like probably Mondays, if that's good with everyone. And then also a build time. So and this is all team decisions, so I'm just I'm not speaking for the team. I'm just, that's what I think we should do, but we should all make sure that everyone can like reliably be there. You know, if it's crazy for someone's schedule, or if it seems like too much to meet up twice a week. And of course, like, if there's any type of testing or anything like that, we'll probably skip weeks and put the project on hold so that we can focus on academics and things like that. So yeah, if you guys have any questions, because I can't see any comments on my phone while I'm doing this, but if you guys have any questions, then just get on the group chat, of course, and ask whatever you got to ask, and I can make like a better, maybe structured video or something. But I gotta go pick up my kids now, so all right, we'll talk to you guys later.